During this video, we are going to make a problem of stoichiometry in which we do not have a mole problem. This is going to be either a mass mole problem or a mole mass problem, okay? Because this is going to be solved differently from what we saw in the previous video of mole problem. If we look to this question, we have that says for the next reaction, how many moles of NaO are produced when 57.7 grams of sodium react, okay? So the first thing that pops to our side is that we have the word moles here, and we have here the word grams. So we cannot say that this is a mole problem, okay? Because we have here moles and here we have grams. Therefore, we have to solve it in a different way. We have to use, instead of the small box that we used in the previous video, we have to use the big box, okay? The big box is a procedure that includes the molar masses of the compounds, and what we are going to be doing is we are going to transform the grams into moles in order to solve it as we saw it previously, okay? So just by looking to this question, we have mole grams, so this is a mole mass problem. If we have a mole mass problem or a mass mole problem or a mass problem, we are going to solve it in the same form, okay, that we are going to be doing in this video using the big box, okay? So the next thing to look for, since we have determined that this is a mole mass problem, is we have to check if our equation is balanced. Just by looking to the equation, we are seeing that we do not have coefficients, okay? So it's either that all of them are 1 or that the equation is not balanced, okay? So in order to do that, we have to check first if the equation is balanced, okay? So we check the elements. We have sodium, we have oxygen. And remember that to check the equation to see if it is balanced or not, what we have to do is we have to check how many atoms do we have of each one of the elements. So we have reactants and products. What we have to check is we have to count how many atoms of sodium do we have in the reactant side and how many atoms of sodium do we have in the product side. Remembering that reactants are the things that we have on the left side of the arrow, okay? And products are the things that we have on the right side of the arrow. Reactants are the things that are going to be interacting in order to form the products, okay? So how many atoms of sodium do we have in the reactant side, okay? Reactant side are the things that we have here, for example, in yellow, okay? So we only have 1 atom of sodium. And how many atoms of sodium do we have in the product side? Products are the things that we have here in blue, sorry, in green, okay? So how many atoms of sodium do we have in the product side? We have 2, okay? This number 2 indicates to me that I have 2 atoms of sodium. Since I do not have a number here out front, it means that we are multiplying, or it's inferred that we are multiplying this 2 times 1. Okay, let's see oxygen. How many atoms of oxygen do we have in the products, in the reactant side? Okay, the things that we have in yellow. So how many atoms do we have? 2. And how many atoms of oxygen do we have in the product side? 1. Okay, so just by looking to this, we can see that the equation is not balanced. So I have to balance sodium and I have to balance oxygen. In order to do it, what we have to do, or what we are going to be doing, is I have to add coefficients in order to balance. So the first thing that I'm going to be balancing is going to be the oxygen, okay? Since I have 2 oxygens on the reactant side, I'm going to be adding a big number 2 out from here, okay? And now what I'm going to be doing is I'm going to check sodium in order to see if it is balanced, okay? Just by looking to the product side now of sodium, instead of having 2, I have 4. And in the reactant side, I have 1. So what I will have to do is I have to add a big number 4 here in order to have my equation balance, okay? So now I have 4 atoms of sodium in the reactant side, 4 atoms of sodium in the product side, 2 atoms of oxygen in the reactant side, and 2 atoms of oxygen in the product side. Because this number 2 that I'm adding here, remember that affects everything, okay? So it means that it has, or that it has to be multiplied times this number 2 of sodium and this number 1 that we have in oxygen, okay? So now that we have our equation balance, we can solve this problem mole mass doing the big box, okay? Remember that to do the big box, what we have to do is we draw box, okay? We divide it by 4, okay? Like this. It seems complicated, but it's not, okay? In the first row, we are going to write the elements and their molar masses that are appearing in the question. In the second row, we are going to write information about the reaction. Here, information about the question, okay? Just let me make this a little bit smaller if I can. Just let me make it a little bit smaller. Okay, there we go. So here we have question. Okay, how do we fill the information in this big box? Remember, in the first box, okay, the one that I have here, I am going to be writing the first element or compound that appears in my question, okay? So which is the first element or compound that appears in my question? If we look to the question, it says how many moles of sodium oxide? So I'm gonna be writing here Na2O, okay? Are produced when 57.7 grams of sodium react. Okay, I'm gonna skip this box, this next one. And in here, I'm gonna write the second element or compound that appears in my question. In this case is sodium, okay? In the 2 empty boxes, I'm gonna be writing the molar masses of sodium oxide and sodium. Remember that the molar mass is the sum of all the atomic masses of the elements forming a compound. So if I have Na2O, okay, I know that the atomic mass of sodium is 23, oxygen is 16. So if I calculate the molar mass of sodium oxide will be 23 times 2 plus 16, which is 62. Okay? This 62 is from here, 23 times 2 plus 16. And in here, I'm going to be writing the 23 of sodium. Okay? Here is 23. Remember that the atomic masses, you will get it from the periodic table. In this example, we are using round atomic masses. Okay, if your teacher or if the exam tells you that you have to round it to 1 decimal or that you have to use a certain pattern in the way that you have to write your atomic masses, be sure to consider it, okay? So now, in the first triangle, we are going to be writing the moles of sodium oxide that we have in the reaction. Remember that moles is the big number that we have out front of the compound in the equation, okay? So which is the big number that we have out front of my equation of sodium oxide? It's a 2. And which is the big number that we have out front of sodium in my equation. Here goes the 4. Okay, once again, this 2 is from the equation, the big number that we have out front of sodium oxide. And this 4 is the big number that we have out front of sodium, okay? In this triangle, okay, this one that I'm pointing out in yellow, we are going to be writing the multiplication of what I have in diagonal, which is the moles times the molar mass. Okay, what we are doing is we are transforming the moles into grams. So if we multiply 62 times 2, we are going to be getting as an answer 124. Okay, the same here. 23 times 4, we get a 92. Okay, so now we have the grams of sodium oxide and the grams of sodium that we have in our reaction. And the next thing to do is we have to look to the question. It says how many moles of sodium oxide, this is my X, are produced when 57.7 grams of sodium react, okay? Very important thing to point out, what we are going to be getting here from this X is going to be grams, okay? Because we are multiplying grams of Na times grams of NaO divided by grams of Na. Okay, so our answer will be grams. If I want to, if they are asking me for moles, I have then to change it to moles, okay? So how do we solve for this problem, okay? As we did it in the previous mole problem, okay? What we have to do is we multiply what we have in diagonal, okay? And we divide by what we have in horizontal, okay? So the answer for this will be 57.7 times 124, okay? Divided by 92, okay? Which will give us as an answer 77.7 grams of sodium oxide. Remember always to write the units, okay? But they are not asking us for grams, okay? They are asking us for moles, okay? Here at the top it says how many moles of sodium oxide. So what I have to do now is I have to change, okay, this 77.7 grams to moles. The way to do it is I just divide this number by the molar mass of sodium oxide, which is 62, and I will get the answer, okay? So I'm gonna write it here at the top, okay? In this case would be 77.7 grams divided by 62. So our final answer will be 1.25 moles of sodium oxide, okay? And this is our final answer, 1.25 moles. Okay?